A current flowing through a wire will generate a magnetic field. If that wire is formed into a coil, then if you put the fingers of your right hand into the direction of the current flow, your thumb will point in the direction of the magnetic field in the center of the coil. So switching the direction of the current around the coil will switch the directions of the magnetic fields. And in fact, the magnetic field associated with a current flowing through a coil is very similar to the magnetic field associated with a bar magnet. In this figure in your textbook that is illustrated, where on the left-hand side is shown a current flowing in a circle and the associated magnetic field lines. And again, if you put the fingers of your right hand in the direction of this current flow, you'll see your thumb will point in the direction of the magnetic field in the center of the coil. And here's the magnetic fields associated with a bar magnet, and you can see the similarity between the field produced by the current carrying coil and that of a bar magnet. If we fix the bar magnet, then the coil is going to be either attracted or repelled from the bar magnet depending on the direction of the current flowing through the coil. And we're going to use this concept to build a transducer to convert the electrical signal flowing through the coil into an acoustic signal, or in other words, a loudspeaker. And we will build this loudspeaker by attaching the coil to a membrane, and so as the coil is attracted or repelled, the membrane will vibrate and launch an acoustic wave. This cup is going to be our loudspeaker. I have a coil here that is formed from 30 gauge magnet wire, and there's 40 turns, and it's attached to the bottom of the cup. So the bottom of the cup will be our membrane, and the coil is attached to the output from this CD player. So our permanent magnet is going to sit on the table here, and I have a spacer to hold the cup above and in close proximity to the permanent magnet, so the coil is very close to that permanent magnet. I'll now turn the CD player on and increase the volume. So that sound is emanating from the cup. Now if I raise the cup, I'll be increasing the separation between the coil and the magnet, and so the force will decrease on the coil and we will lose the sound. So now let me hold the magnet close to the coil.